All right, we are now ready to actually get a mathematical formula for the consumer and producer surplus. So proposition 5.4.2, consider the following demand and supply functions. I have the demand function right here. I have the supply function right there. I have the equilibrium point at a price of P0 and a number of unit X0. The consumer surplus at the price P0 is the area below, well, it's going to be this area we said. All right, so let's put it all. This is P0. So it's going to be the area above y equals P0 and below y equals d of x. So this area here, this is x0. And so we know how to compute these areas now. It's going to be the integral top minus bottom. So top is d of x. Bottom is just P0, just a constant, dx. And my x go, well, they start at 0, and they go all the way to x0 here. Where x0 is such that, well, it's d of x0 is P0. Right, sometimes we'll give you the entire points, sometimes we'll just give you one of the two, x0, p0, but they relate to each other in this way, so once you have one, you can find the other one. All right, so this right here, that's the consumer surplus. Now the producer surplus, we could do the same thing we did in the last example for on the side of producers, and what we'll get is the producer surplus is going to be this area right here. So it's the area below that blue curve y equals P0 and above the supply curve, this supply curve y equals S of x. And so the producer surplus will be, well, it's an area, so it's an integral. Again, the bounds are the same from 0 to x0, but now top is the equilibrium price and bottom is the supply curve. So, sorry, minus S of x dx, where x0 is such that S of x0 equals P0. I mean, if it's the equilibrium point, then these two are equivalent, but I might not be giving you both curves. I might just give you one of them, and so you could use S or D, depending on which one you have. All right, let's do an example. Assume that the demand function of an iMac is d of x is equal to 1200 minus 0.2x. Find the consumer surplus when 500 units are sold. So I'm given units, and so that's going to be the x0. And now P0 is d of x0, so it's 1200 minus 0.2 times 500. So that's 1,000. So it's no, it's 100. All right, it's like $200. I'll buy it. Yeah, so that's 100. So it's 1,200. Yeah, it makes more sense. All right, it's 1,100. So that's the price that we're talking about. All right, so now consumer surplus. We said that's the integral from 0 to x0, the demand function minus the price that we're looking at. So in this case, that would be the integral from 0 to 500 of d of x, which is the function we're given, minus the price that we're looking at, dx. And so we're integrating 100 minus 0.2x. That's 100x minus 0.1x squared from 0 to 500. All right, so I've computed what we get, and we get $25,000. All right, so for these questions that are real life, I'd like to get an answer which is a full sentence at the end. So here I would say the consumers are saving $25,000 because they're paying, so by paying $1,100 instead of the maximum price they were willing to pay. So that maximum is different for each consumers, and so it's harder when you think about it to compute it because you would have to do a different price for each consumer and add it all up. All right, but the integral does that for us.